All right, so we're going to start off with some kinematics basics, basically just defining some of the terms. In the future, you're going to get all of this from your reading. Okay, so I'm going to give it to you today, but in the future, this is going to be in your reading. All right, so position. Position is basically where you are. Okay, so I'm at x equals 3 meters. I'm there. If I'm doing GPS, I'm at 15 meters or 15 degrees longitude, 65 degrees latitude. Okay, so that's where I am. Just where do I start? My displacement is basically my change in position. How far have I moved from where I'm started? So if I started here and I moved there, my displacement is just the straight line distance between the two. Okay, so this triangle, this is the first time you've seen that triangle maybe. This triangle means change in. So you're going to see it a lot in physics. It's another Greek letter, the Greek letter delta. So you've seen your second Greek letter. And so that means change in position. The distance is distance. Distance does depend on your path. So this depends on the path. Your displacement doesn't. So if I went, let's just shrink this real quick. So here I am, I started here and I ended here. My displacement is that distance. Okay. My distance is how far I went to get there. So it does depend on my path. My distance and my displacement could be the same if I didn't change directions at all. If I just went straight from A to B, then my distance and my displacement are the same. But if I took a curvy path, or like, here's a tricky one. If I went from here to here and then back to here. So I went here, then there, and then back to there. How far have I changed my position? If I arrived at where I started, my change in position is 0. I ended up where I started. So it's the same spot. So my displacement is 0, but my distance is the distance there and the distance back. All right. So distance, displacement. Displacement is a vector quantity, which means it has magnitude and direction. So for here, for the first one, my displacement is this many meters to the right. Okay? Here my displacement is 0, and 0 doesn't have a direction, so it's not a big deal. Distance is a scalar, so it doesn't have direction. So notice I winded all over the place, and I just say I went 100 meters, not I went 100 meters to the right. So that would be displacement. Okay, so we tend to think of our velocity and our speed are very similar ideas. They're very, very, very similar. They're basically how fast are you going? Okay, they're basically how fast, but velocity is our vector. So velocity has direction. So I went 10 meters per second to the right. I went 10 meters per second to the left. I went 10 meters per second east. I went 10 meters per second west. And it is your displacement divided by your time. Because remember, what do we measure velocity in? Meters per second. We learned that in our buggy lab. So displacement's still a meters. It's a distance. It is a distance. It's just a distance in a direction. So velocity is our displacement over time. Speed is our distance divided by the time. So that would be the difference between them, but they're still both measured in meters per second. And if you're always going in the same direction, so if you don't change directions, then your velocity and your speed are exactly the same. Another way to look at velocity is that it is your change in position divided by time. Because remember, that's displacement, isn't it? Okay, and then the last term, acceleration, is your change in velocity divided by time. Okay, or your change in speed over time. Think of acceleration. You know acceleration. How do you go faster in your car? You step on the accelerator. And what happens when you step on the accelerator? You change your velocity. See? And then, so you have meters per second divided by seconds. Okay, remember when you're dividing fractions, you multiply by the reciprocal? So that's meters per second times 1 over seconds. So the unit for acceleration is meters per second squared. And it is your change in velocity over time. And the unit gives meters per second squared. Now, your acceleration can be positive and it can be negative. Okay? A lot of times when we're slowing down, we call it deceleration, but that's still an acceleration. You're still accelerating. You're still changing your speed. Okay? So the variables used for these things, a lot of times, remember displacement and distance, they're both in meters. So remember they're both in meters. And so they could be measured in the same thing. Remember, your displacement and your distance are the same as if you're going in a straight line. So the unit we use for, or not the unit, the variable we use for displacement is x, and that should be on your handy dandy equation sheet. Then you have your initial velocity. We use vi or we use v naught. So v initial, that's what the I would mean. V naught means v at time 0. Your final velocity we call vf. How original is that? Vf, so v final. Sometimes we just write v, because that means v at some point, because it's not necessarily the end, it's just the velocity at some point. So sometimes they just write v. Your average velocity is your average over the time frame. So like when you're driving from home to school, you're not doing 65 the whole time or 45 the whole time. You know, you're going fast sometimes, you're going slow sometimes, and so all of that averages out. So you can see it as v av. Some books will write it v with a line over it, but most of the time we're going to see v average. Acceleration, see, we didn't get too creative. Acceleration is just a. Hey, how about that? And then time is a t. And notice I made that t with a hook. I'm going to reiterate that later. But that's so you don't get your t's and your plus signs mixed up. Now, one of the things is we sometimes call this final velocity, we call it instantaneous velocity. So sometimes it's written as instantaneous velocity. Because it is your velocity at a certain instant. So notice it's not always the end. All right, so velocity-wise, we have, if I go velocity that way, so if I have a velocity to the right and I have a velocity to the left, okay? If they're the same magnitude meaning size, they're the same magnitude and opposite directions, so what we do is we make the opposite direction negative. So if you think of a number line, there's 0. This is the positive direction. That's the negative direction. But you actually have the power to assign positive and negative directions. If everything you have is moving to the left, does it really make sense to make left negative? If your distance is negative and your velocity is negative and your acceleration's to the left and negative, doesn't it make sense to not use negative numbers in your calculations and make it positive? So all that positive, negative tells us, and this is a huge, big thing in physics. Positive, negative in physics shows direction. And this is a huge, big thing. So if things are in opposite directions, if you have one thing going one way, one thing going the other way, then one of them needs to be negative. All right, so move on to the next one so that you can get how to use these pieces of information.